Hi everyone, welcome to my YouTube channel. And today we will be solving the question of linked list cycles. So here we will be looking into two problems at once. So the first problem is linked list cycle and another problem is linked list cycle 2. So here we are given this linked list where head points to node 1, and as you can see it goes to node 3 and then node 4, node 5 till node 8, and then again node 8 points to node 3. So here as you can see there is a cycle here. So here what we have to do is we have to return true if there is a cycle in the linked list, and we have to return false if there is no cycle. And for our second problem, what we have to do is we have to return the node where the cycle of the linked list is starting, as we are traversing from the head pointer. So as we traverse from the head pointer, as you can see at node 3 we enter this cycle. So we have to return this node 3, and that would be our answer. So to understand this, let's have a look at the next diagram. To understand this problem, we'll have a look at a famous algorithm which is called Floyd's cycle detection algorithm. So to understand this algorithm in a simple way, we'll make use of an example of two runners running on a racetrack, and we won't go too much into the mathematics as it would be easier to understand this using this example. So let's say there are two runners. The first one, his name is Parth, and second is Harshit. So Parth can run at a speed of 5 meters per second, and Harshit can run at a speed of 10 meters per second. And the length of the cycle is 100 meters, which is the circumference, and the distance between point A to point B is 10 meters. So let's see what will be their position after 2 seconds. So in 2 seconds, Parth is going to cover a distance of 5 into 2, 10 meters, and Harshit is going to cover a distance of 20 meters. So let's try to draw their positions after 2 seconds on our diagram. So Parth is going to be here, just at the entry point of the cycle, and Harshit will be 10 meters ahead. And as we know that they are going in clockwise direction, and Harshit's speed is 10 and Parth's speed is 5. So from relative motion, what we know is if we keep the frame of reference on Parth, then Harshit's relative velocity will become 10 minus 5, 5 meters per second. And since they're going in a clockwise direction, so the distance between them will be 100 minus this 10 would be 90 meters. So the time after which they're going to meet is going to be 90 divided by 5, and what it's going to be? It's going to be equal to 18 seconds. So let's try to find their positions after 18 seconds. So in 18 seconds, Parth is going to cover distance of 5 into 18, that is 90 meters, and Harshit is going to cover a distance of 10 into 18, which is 180 meters. So let's try to draw this on our diagram. So let me draw a circle here, and as we know that Parth was here, so 90 meters would be somewhere here, as the total length is 100 meters and Parth will cover 90 meters. So Parth is going to be 10 meters from his original position, and Harshit was originally 10 meters above, and after covering 180 meters, where is he going to be? So in one cycle he's going to cover, in this one cycle he's going to cover 100 meters, and this is 10 plus 10 20, and he only has to cover 80 more meters. So 80 would be this, and Harshit's position is also going to be same as Parth's position. So let's try to draw this again. So now both Parth and Harshit, they have met, and they have met 10 meters below the start of the cycle. And since they have met, which means that there is a cycle in our path, or there is a cycle in our linked list. So let me call this point A, this was point B, and this was also 10 meters. So in our algorithm, what we are going to use, we are going to do what we are going to do is we're going to have two pointers, and first pointer we're going to iterate by only one step, and the second pointer we're going to move it by two steps, and at some point they're going to meet, and when both the pointers are equal, then we can return true. And if there is no cycle, then we are going to reach a null element, and in that case we can return false. So now the next step is to find the start of the cycle. So as you can see that they have met at 10 meters below the point B, and this distance was also 10 meters. So now if I reset their positions and move Harshit to starting position at point A and keep Parth here, and now if I move both of them at same speed, let's say 5 meters per second, now what is going to happen? Since they are at equal distance from point B, so they're going to meet at point B, and this point B is also the start of our cycle. And when they have met, we can simply return that node, and that node is going to be the start of our cycle. So in this example we used a distance of 10 meters. Now what if D was 0? So in that case what that means is they both started somewhere here, and Parth is going at 5 meters per second, Harshit is going at 10 meters per second, and this whole distance is 100 meters. So again following the relative motion, now after how much time they're going to meet? They're going to meet after 100 divided by 5, which is 20 seconds. And in 20 seconds, how much distance will have Parth covered? It would be 100 meters, which is this one cycle, this one whole cycle, and Harshit would have covered 10 into 20, 200 meters, which is two cycles, and that would be the first time they would have met, and they will meet at point A. So regardless of the distance D, as long as their relative speed is x meter per second, then it is guaranteed that they're going to meet at the same distance from the start of the cycle. So let's say if this is distance D and this is our cycle, then it is guaranteed that both of our runners are going to meet at this position, and then we can reset the position of one of them and can make them run at same speed so that they can meet at the start of the cycle. So here, as we discussed, that we need to implement this has cycle function. So as we discussed from our Floyd cycle detection algorithm, we have to use two runners. So in this case, the two runners, let's name it slow and set it as head initially, and let's name the second one as fast, and it also begins at the same position, and let's call it head. So as we know that slow is going to move two steps forward, and we are going to set it as slow.next, and fast is going to move two steps, so it is going to move till fast.next.next. So since fast is going faster, what we can do is we can do null checks on fast pointer itself. So here in this case, what can throw null pointer exception? So here, if fast is null, then fast.next can throw a null pointer exception. And if, let's say, fast is not null and fast.next is null, then fast.next can throw a null pointer exception. And since we are checking fast, we don't need to check slow, since fast pointer is faster and we have already checked it. So in our while loop, we are going to have condition where fast is not equal to null and fast.next is not equal to null. So here we can simply move slow equal to slow.next and fast as fast.next. And if slow is equal to fast, then we can simply return true. And if at any point they reach null nodes, then this while loop would finish and we can return false. And let's try to run this, and it says runtime error. So what happened here? Fast, what does it say? Fast.next. Oh, it would be fast.next as we discussed. So let's try to run it, and yeah, it works. Perfect. So now let's have a look at the second problem. In this problem, we have to return the node where the cycle begins. And as we discussed in our Floyd cycle detection, we have to first find the node where the two runners are going to meet, and then we have to reset the position of one of the runners and make them run at same speed, and then we can find the start of the cycle. So let's use same variable names from the first problem. So let's call them slow and fast, and again slow is going to move forward by one step and fast is going to move forward two steps. So we're going to have same checks here, while fast is not equal to null and fast.next is not equal to null. What we are going to do is slow.next and fast is fast.next. And if slow is equal to fast, we can break out of the while loop, and if there is no cycle, then what we have to do, we have to return null. So if, let's say, this while loop finishes and reaches a null node, then what is going to happen? Then our fast node is going to be null. So if fast is null, then we can simply return null, and if it's not null, then that means we have reached a meeting point where slow and fast, both of them are going to be equal. So let me reset the slow pointer again. So since the slow pointer is already slow, so let me reset the fast pointer at head, and now both of them are going to move one position forward. So now what I'm going to do is, till both of them are equal, what I'm going to do is I'm going to move both of them forward by one step, fast.next. And also, so here we don't need to check if slow is not equal to null and fast is not equal to null. This is because if we reach till here, we already know that there is a cycle and we are never going to reach a null element. So that's why we don't need to do null checks on slow and fast. So after we come out of this while loop, we can either return slow or we can either return fast, since these two pointers are going to meet again. So here this if check, so here can there be a case where fast is not null? Yes. So when there is only one node in the linked list, what is going to happen is this while loop is not going to execute because there is only one node, and fast dot next is going to be null. So in that case, slow pointer is also going to be at head and fast is also going to be at head. So fast is not going to be null, and this would lead to wrong answer. So here we need to add another check of fast.next is equal to null, and then we can simply return the null node. And here if we reach till here, then we know that there is a cycle and there would be a starting point of a cycle, and we can simply return slow or fast here. So let's try to run it, and yeah, this works, which is good. Thank you so much for watching, and I'll see you in the next video. Please like and subscribe to my YouTube channel, and I'm continuing to make all the LeetCode videos, and I'll see you in the next one.